minutes for Q&A at the end. I'll leave it to you, gentlemen.
One, two, 1, 2. Yeah, now it works. So if you're planning to run Postgres databases now, it's important to decide where to run the database, but also the reasons behind that decision. So why? So nowadays, there are so many options. Most of them are outside Kubernetes. So for example, public DBAs or traditional VM setups. But one option that is becoming very, very popular is to run Postgres inside Kubernetes. This approach brings an enormous benefit. We call it cloud neutrality. There's going to be a blog of mine on the CNCF blog next week about this topic. And cloud neutrality for PostgreSQL allows you to run it everywhere, removing vendor lock-in and allowing you to port the data anywhere. So welcome. My name is Gabriele, and today with Leonardo we'll talk about running Postgres inside Kubernetes with CloudNativePG. And also we will talk about an extreme use case, running Postgres as a microservice database directly integrated with your application. So I'm Gabriele. I've been using Postgres for over 25 years. I'm a Postgres contributor. I'm also Data on Kubernetes ambassador. And I'm a big DevOps and Lean fan, and they are the reasons why I came to Kubernetes. I'm an open source contributor, and I have contributed to Barman. I'm the founder of Barman. It's a popular open source backup and recovery tool for Postgres, and also CloudNativePG, of which I'm a maintainer with Leonardo. And I work for EDB as Vice President, Chief Architect.
Hi, I'm Leonardo. I work in EDB as Gabriele. I'm a principal software developer. I'm a Kubernetes CSI member and contributor too, so it's really great. And I'm a maintainer of CloudNativePG, and I work for CloudNativePG in EDB too. And I've been using Postgres for many years. Yeah, that's it, you know.
So just a reminder that tomorrow, as a Data on Kubernetes ambassador, I invite you to come to the Data on Kubernetes Day. And also, if you're interested about the Data on Kubernetes community, if you scan this QR code, you can learn more about this community and you know, our initiative to run stateful workloads in Kubernetes. Thanks, Leonardo. This is also a talk that a panel I will be part of on Wednesday. And you're more than welcome to participate about the future of DBAs in Kubernetes. So first part, I guess everyone knows Postgres. Is anyone in here that doesn't know Postgres? Okay. So I just put some reasons why people use Postgres today. It's the most popular database in the world. And so I'll just move forward, okay? So I want to go through the 5 eras of Postgres deployments. Okay, we started on bare metal, then we progressed on VMs, then infrastructure as a service, so VMs on AWS and so on, and then the DBAs options came. So this is a very popular option to run Postgres on, for example, RDS or Azure Cloud and so on. What I'm going to focus about is this new era, which I call cloud neutral, that is based on Kubernetes, both as a self-managed Kubernetes or a CaaS, Kubernetes as a service. That's why cloud neutral is an important concept, because we can use the same resources and port what we create on everywhere, on private, public, hybrid, and multi. So CloudNativePG, in a slide, it's a production-ready operator. I want to stress about the license and the vendor neutrality and the open governance of the project. That's why it will always free. It will always be free. It was originally created by ADB, which is also one of the major contributors for Postgres. Our mission is to run Postgres everywhere. And we applied for the sandbox a second time 2 months ago. So hopefully this time we will get accepted. You can install it everywhere, but you can see in 2 years we've reached about 4,600 stars on GitHub and 60 million downloads for the operator. Of course, the reason is that it's used in CI/CD pipelines, which is one of the main reasons why we had the operator. Briefly, this slide is here only for this QR code. If you want to know why we don't use stateful sets and we use directly PVCs, this is the reason. It's explained in that page. So I'll move forward. So CloudNativePG in a minute. CloudNativePG is described by this CRD, okay? There's a cluster resource. We follow convention over configuration. In this case, I request 3 instances for the Clapton cluster. We set affinity. We also set synchronous replication, which is a concept in Postgres because we don't use storage level replication. We use stream replication in Postgres. And 2 volumes, one for the storage and one for the write-ahead log, which is the transaction log. So what happens is this. Once we create the cluster resource, and suppose we have a Kubernetes cluster with 3 availability zones and multiple nodes with the Postgres labels, we start with the PVCs. Then we start the Postgres primary on top. This is one of the reasons why we control directly PVCs. Then the read-write service is created to point to the primary. Then we create the first standby and the second. And one is synchronous and one potentially synchronous. And then the read-only service. So what happens if there's a failure? So suppose the first worker goes down. The controller basically removes the pointer to the former primary, promotes the new primary, and automatically redirects the endpoint of the service there. Then, when the other worker node comes back again, the operator transforms that into a standby. So let's go quickly over the main use cases. This is normally the way you run Postgres today. Okay, you write your own application, you have your CI/CD pipeline, you deploy the application in a Kubernetes namespace, but you're afraid of running Postgres in Kubernetes, and you access a database in the cloud, for example. The second one is whether you decide to use Kubernetes to run Postgres, but you are afraid to run it inside the same namespace of the application, and you provide, for example, an internal dbus service. What we want to bring today is actually the reason why we created the operator, is to run the database together with your application. So when you create a feature for your app, use the database, use Kubernetes to test the feature you deploy, and enhance the velocity of your application and make it more robust. The idea is to rely on you can leave, you can go ahead. Postgres has this feature called transactional DDL. So you can begin a transaction, create tables, or destroy them, and then roll back, and nothing happened. So if you have a 10-step migration, you can begin the transaction, do all the steps, and if one fails, you can roll back. Here I put the main DevOps capabilities, which are in orange here, that you can actually implement with CloudNativePG. So let's start from the left. You are the developer. You write your own the code for your application locally. You run tests locally. How? With kind. You can use CloudNativePG with kind to test your application. It works. you issue a pull request of your application with the feature you developed. You have automated pipelines, so these are DevOps capabilities. Version control, you have Git, test automation, and shift left on security, because maybe you also scan for the code or for the container images that you build. And then you use the same container images to run end-to-end tests. So you build container images in your pipeline, and you use the same environment. Okay, no variability. That way you can apply continuous integration and also test database change management with migrations through transactional DDL I was mentioning. When everything goes well, you merge your main, continuous delivery. So it's your posture to make sure that your software is always running the best version of it. And trunk-based development. You can find them out, okay? You can search for these capabilities, they are very well known. And then depending on the release policy, you publish on a public registry or your local registry and you deploy. You can have automated deployment and ensure that database change management is part of that. And then the end user. Remember, lean. Lean is about creating a highway between you, your product, and the end user. So now I think it's your turn, Leo. Okay, this is important. You have two feedback loops, one local and one with the end-to-end tests. Okay?
And now we are talking a bit about how this stuff works practically. Okay, so again, this is a simplified version of what Gabriele was explaining before. It's the same cluster definition, the name changes, name PG, and here you see there are two different storage areas, one for your data, that's name storage, and one is name wall storage, that's for the transaction log. In this example, I use the same storage class. It's just an example. Since the access patterns that the storage get impacted for the two different storage are totally different, you can choose to have two different storage classes with different performances. It's fine. And let's try to, in the meantime, we are talking about this. If my friend T-Max is still here, we apply this magic PG cluster. Yeah. Okay. I'm using CloudNativePG just to demonstrate what is going to happen, but these concepts are generic. This is just the operator I know best, and I'm a maintainer of CloudNativePG, so that's it. Meanwhile, this is working. The first point of the database is being useful for the application. Why being useful for the application? Because this is how you help users. That's the main point. Our value added as programmers is to help people. This is why you need a database in the end, but the database per se has no meaning without an application. So database should be helpful. This is why our operator is creating a lot of resources that are really needed for just the application to connect to the database. In this example, you see this secret, PG APP. This is useful for the application to connect to the Postgres database. And then you see this RW service. This is, again, this is useful for the application to connect for read-write traffic, okay? So it will not target replicas, that service there. Let's have a look at them. Meanwhile, our friend is downloading the images, it's fine.
Of course, I forgot to mention, there's one primary only with Postgres. Okay?
Yeah.
It's primary standby architecture. But it can scale.
Yeah.
Okay.
So let's have a look at that. As you can see, it's nothing fancy. It's just your username, your password, and a set of useful URI for your application to use. Nothing fancy. But the most important bit here is that if you look inside your Postgres, I'm using the CMPG kubectl plugin to do that. It's just an exec call, nothing fancy. You see there is just one database, it's named APP, it's just the default, you can name it as you like. But this is your application. Look, one Postgres cluster per application. This is the underlying concept of the microservice database. And not only this, but you have oh, maybe that's too much. Oh, this is better. A user to connect. This is the one corresponding to the secret we were looking at before.
And also, it's not super user.
No.
Okay.
Shadow.
By default, we disable super user access
Sorry.
to the database. Every change needs to go through the YAML. I actually did a patch for Postgres 17 for this.
Yeah.
Okay, to remove access.
Yeah.
To disable the alter system.
No super user, just your password, but because a reasonable question would be, okay, why guys you just don't use MTLS or integrate with Spiffy to do that? It's reasonable and you can actually do it, but this is for simplicity because there are still a set of Postgres client libraries that unfortunately are not able to log in to authenticate via MTLS. So this way you can use them. And if you want to create a certificate for your APP user to use, it's just one kubectl CMPG invocation that you should do. That's it, no more. And again, we need to be useful. A database alone is not really useful because it's empty. You need a schema. And I love this quote. It's actually 1975, so I wasn't even born, but it's really powerful. And it's more, show me your tables, and I won't usually need your force chart. It will be obvious. What does it mean? It means that your schema is basically what you are perceiving about the problem you are trying to solve. So this is really important. It's, you know, schema-less databases are really comfortable to use, really ergonomic, but I still think, just my personal opinion, that the mental discipline you have when you design a schema is useful per se, even if you choose to use a schema-less database. But you know, your understanding of the problem changes over time, and the problem changes itself. So you are going to change your schema, this is life. Nothing gets still. If something is still, it's not useful. We need to be useful. And what happens? It happens that you need to change your schema. How do you change your schema? With migration. That's the technical name for changes in the schema. But on the practical side, what kind of migrations trick can we use? Or there are two different approaches. The first one is the declarative. The second one is the change-based. The declarative is somewhat new. There is a really good product, it's named Atlas, that lets you use the declarative approach. Declarative means just everyone is used with Kubernetes here. So it's just, look, this is the schema I want to have. Your magic migration box will detect the SQL DDL to apply to your database to get the schema inside. It sounds magic. And then you have the change-based migration. This is what we are used to. Everyone is used to writing change-based migration, whether in SQL or in different languages. And that means you have a migration engine that connects to your database, get the current version, and then you have a set of scripts that are migrating the previous version to the new one. And the migration engine will apply the scripts that are needed. and then it stores the new version inside the database. More practically, the declarative migrations day one. Oh, look, I need to store a set of people. Great, let's create a table, really simple one, and I put just the address here. It's fine, just to begin, it's totally fine, okay? And this is easy to apply for a declarative engines. Just throw inside, create the table, and you are done. Beautiful. Day two, and then you realize, oh my, there are many addresses for a person. I need to create a separate table. And I create one. It's great. My database is relational. It's just a foreign key away. Beautiful. Now I have a table. And now my magic migration box needs to migrate this stuff here with these fields that could be full of data inside this. Is it really smart enough, my engine? Okay, Atlas is really good, but still, that's what is going to happen. Primary headaches. And by the way, this article is really nice to read. And why it's called primary? It's called primary in physiology because it doesn't have explanation in other phenomena. It's you have a headache because you have a headache. That's it. It could be a lot of different points why you have a headache, but you don't really know. And that's the problem you usually have with these engines, to let them understand what you are trying to achieve. By the way, still, you get an headache. Change-based migration are more painful. The day one is just the same. And just create a table, it's fine. Day two, still, now it gets more convoluted. I need to create a table. Then I need to insert in the new table every address that was stored in the previous version of the table. But look, I need to tell my SQL engine, I need to lock these rows, otherwise they are going to change. Okay? And then I can just drop the column.
This is all Postgres,
yeah.
SQL, standard SQL.
Yeah, okay. This is standard SQL actually.
Very powerful.
Yeah, it's really powerful,
They
this stuff here.
Concurrent. Okay.
But again, the point is, whether engine you need to use, take care about how this stuff is implemented, because it has different performance aspects that you can use for Postgres, MySQL, whatever you like.
And these are, for example, 2 transactional DDL instructions.
The main point is begin and commit. But to do that, to do this stuff here, so you need to understand, as I was saying before, what's happening inside your DBMS. And there are people that are just vertical on that. They are called DBAs. They're these guys with long beards, pretty with people, but they are useful for this kind of stuff. And sometimes you don't have a DBA to work with. Is there a middle way? Yeah, there is one. You can use your declarative migration magic box to scaffold a SQL script for you, and then you review your script. Because we are still humans with our brain, and we need to get this value added inside the engine. That's the main point. So you can combine both approaches. It's good. It works beautifully. So now we have reached a point where we have a migration strategy. We need to understand the safety of what we are trying to do. So, what should a migration engine do? The change script should be applied entirely. You don't want to get in the middle, because otherwise you are in the middle of the bridge, and you don't know where you are. The change script needs to lead to a consistent state. I mean, the constraints must be respected before and after. And it should not conflict with other queries. Look, this is not A, B, C, D. It's magic. Once committed, should not ever be forgotten. This is the axiom 1. ACID, this is the main point. You need a transaction. You need transactional DDL in your engine. Postgres has one. So it's a really good DBMS. But should you look for another one, please ensure it does transactional DDLs. Otherwise, you are going to have
30 years.
Point.
So it wasn't implemented in a couple of years.
Yeah. You have seen migration are just SQL code. You need to test them like every other code base. This QR code just leads you to a repo where there is this workflow fully implemented. It's nothing important, just an example of what you can achieve with this concept. But by the way, it's just set up a kind cluster, look 2 lines. This is the syntax of GitHub. You can use the syntax you like best. Install CloudNativePG. It's just a kubectl apply. Easy. Then you wait for it to be deployed. And then you can do whatever you like with install your application and test it. You can test your migrations that way. This is really powerful. And now can you execute them? So if you have your magical migration box, it works per se, it's an operator, it's fine. Otherwise, if you don't have it, you can use an init container if you like. But the point is, in Kubernetes we have several replicas of the application that are working all at the same time. And only one of them at a time should execute the migrations. Your migration engine should take care of that. Postgres has a primitive, it's called advisory lock, that is doing exactly that. So should you look for another DBMS, please ensure you have a primitive to use like that. Please ensure that your migration engine is using it. Otherwise, you're going to be in trouble. And then depending on the deployment rollout strategy you use, you need to be prepared for all versions of your application to cope with the new version of the schema. Otherwise, you're going to recreate all the pods and have a bit of downtime.
So, with that, and then we just conclude, and then maybe have maybe time for one question, or depending on Courtney. Okay. So if you want, there's this blog article I wrote a few months ago that recaps what we talked about today, and the key takeaways. Postgres is the most popular database. Okay, it's useful in most use cases. It will not excel maybe in some specific ones, but it will take you far in most cases. You can break vendor lock-in. So you can have a fully open source stack with Kubernetes, Postgres, and CMPG that is also vendor neutral. You can achieve cloud neutrality, so you can have your Postgres run everywhere. And my advice is to start with the DBaaS approach if you want to run it for your company, or even externally, like many companies are doing, like IBM Cloud, okay, a Cloud Pack. And then follow what Leonardo said, the microservice approach to, build the quality directly into your product, achieve operational efficiency thanks to also GitOps pipelines, then velocity, and then ultimately drive innovation.
We've got time for 1 or 2 questions. Yeah?
Of course, you can visit us at our booth at EDB if you want to talk more, or talk with me and Leonardo outside.
Hey there, thank you for that.
Hi.
Very interesting. A question, maybe I'm asking too big of a question, but what does backup look like? Is there any integrate like locking tables, right, and exporting to S3?
So backup Postgres, I did a talk last year in Chicago with Michelle Au from Google. My suggestion is to go there. It covers a lot, but long story short, Postgres has an advanced backup, continuous backup. Okay, so you can do point-in-time recovery, and it works out of the box. Okay, and we support it. Leonardo is also working on Kubernetes storage for volume group snapshots. So we also support volume snapshots. Last year in Chicago, I showed how to restore 4.5 terabytes in 2 minutes. Okay, in AWS. Okay, so this is just a start. Yeah, it's all done transparently. And believe me, I'm one of the pioneers in Postgres for backup and recovery. And the implementation we've done with volume snapshots is amazing. Yeah. No fear. You know, backups. We have many users tell us that if there are problems with the operator, at least they don't lose data. Because of our PVC, we start from the PVC essentially, okay?
We are working on promoting volume glue snapshot 2v1 beta 1 these days, so it will be amazing. Because they will be consistent. By the way, our volume snapshot implementation is still based on the physical backup infrastructure of Postgres. It's just not a snapshot and then you are out of luck. It's with transaction logs and everything.
All right, we've got time for one more very quick one.
Okay, thanks for using kube control plugins. We'll have a session about that later today. So the question that I had is, how do you handle eviction requests that are coming from drain command and stuff like that? And do you have a way of pushing back on that? Actually, I'm curious to go back to the slide where you skipped quickly over. Why don't you use stateful sets? Yeah, probably the answer is related.
So for example, we support pod disruption budgets. Okay, we have one for the replicas and one for the primary. Okay, so we allow one disruption per replica for the replicas at a time, so that we can perform rolling updates. So essentially, when you drain a node, if there's a primary, we issue a switchover. So the primary goes to another node. Okay, and then we basically shut down the node, restarts as a replica. Yeah, 2 different PDBs.
What if you receive 2 different eviction requests?
Shit, my wife, sorry.
Oh, mama. That was risky.
That depends. I mean, the pod disruption budget might not allow you to maybe the second one. And it depends actually on how many clusters you have on each node, where the primary is. So the idea is, normally you should drain one node, Kubernetes node at a time, okay? But there's a lot of things to learn. There's also tools like Carpenter, I understand, I'm not familiar with, but that are trying to manage that stuff, but yeah.
The operator ensures that your primary always runs in a schedulable node. Otherwise, it switches over. So that's perhaps the main.
Okay. Great. If you want to continue to ask them questions, I think they'll still be here. And also definitely attend Data on Kubernetes Day. They're always
tomorrow morning. Tomorrow morning.
Let's give them a round of applause.
Thank you.